Good, welcome ladies and gentlemen. Today we will talking about financial mathematics a little bit more. So the basic idea is to play around with those functions rather than solve it mathematically. We all know that if there is an annual interest rate of 6%, you basically shouldn't be dividing it by 12 due to the fact that nominal and effective interest rates are to be applied. But for our examples here, we're ignoring that. That means if you have a annual interest rate of 6% and you calculate it to month, simply we divide it by by 12 to get an 0.5 percentage. Now, if we do it for the financial mathematics, there are some kind of abbreviations we can use, like the PV, the present value, FV, the future value or rate, or number of payments, the NPER, or the payment itself means the rate. So we have kind of an idea what the arguments are or what the function names are. And the good part is, for example, if we are calculating the future value, it's FV, and we open the bracket, you see rate, NPER, PMT, PV, and type, which are by default the other function names. Now in our part, the rate is 60, and the number of payments uh, periods in the investment, sorry, is the 0.5%. The 6%, we don't have any payment made each period, and of course if we don't have any payment made each period, type means beginning or at the end of the period is of no interest for us. And if we say the present value is 100,000 euro, if we now go to OK, you see that the future value is minus 134,885 and 2 cent. And that seems to be strange if somebody offers you something like this, but with the financial mathematics, it's not the absolute amount, it's streams. That means changing from plus to minus means this is something I have to pay, this is something I'm getting. So you have to decide for yourself how you want to deal with that, because without the payment per period part, it's of no big deal, because you simply have to be aware that those two need to be differing by the plus or the minus. But later on it might be becoming difficult, and that's the reason why I for myself have decided that if I'm giving away money like the 100,000 here, I will always put it with a minus, because I'm not very happy about giving away money. But if I'm getting money, like with the 134,000 here, I'm taking it as a plus, because I'm very happy about getting money. So that's how I deal with it. If we go to the second task, so Mrs. Berger likes to buy a house in 15 years. Price will be 2 million. What present value has she to invest at the bank if the money gets an annual rate of 4.5%? So we have the 15 years, 4.5%, and the 2 million we want to get out at the very end. And that means we get 2 million, and that's positive. And so what we do is we say, well, the present value at the moment then should see the interest rate, should be kind of the number of payments, and the future value, because again we have no rates, and that means if we now pay 1,033,440 euro and 88 cents, we get those 2 millions in 15 years. If we are checking for the rate per year, it's getting a little bit more difficult, because here we invest 400,000 years, we get back 1 million in 20 years. And if we do it typical way, for equals rate, and then say, well, we have the number of payments is 20, and we have the present value and we have the future value, people will get quite irritated, as this is a typical sign that something went wrong. And in our part, what went wrong is we want to have 400,000 as a payment, and we want to have the million as a payment according to the plus and the minus we used. But due to the fact that we're investing 400,000 euro, we're paying those 400,000 euro. So I personally would put this with minus, and that means if we now pay 400,000 euro, and in 20 years we get 1 million, we're getting a percentage of 4.69. And the same is here for the task down here. The question is we need to make sure that these are calculated quarterly. That means we need to add a number 4 somewhere, and if we now are calculating the number of uh, number of payments, we deal with the typical rate, which is the 8% annually, but due to the fact that we use it quarterly, we divide it by 4. We have still no regular payments. We have a present value, we have a future value, and we have a type, and with the type again is of no use. And again, we need to make sure that something is positive, something is negative, and in this special part I would put the 70,000 or 80,000 negative, due to the fact that this will be the last part that we need to pay back, due to the fact that I hope that we got to 55,000 now, and we have to pay back 80,000 in 18.92 quarters. And that means if here, for example, the question is she wants to know after how many months, we need to multiply that with 3. Or if it says she wants to know how many years, then we go back and have a division by 4 here. So it depends on what the question is for and how you use that. If you have kind of a problem like this one, so you're getting offered a machine with the pricing of 13 million, and you expect it to be getting back an interest rate of 10%. These are the cash flows, and due to the fact that we get those cash flows in the different years, we need to calculate them with the proper interest rate. And another thing we can calculate is the net present value. The net present value, there are several ways of doing so. I'm a big fan of the NPV. That means the net present value of an investment on a discount rate and a series of future payments. And if we do so, we are getting back kind of the rate, which is the 10%, and we're now dealing with the payments, means the cash flows. And so we are calculating down the cash flows, and out of this result we need to subtract the buying price. Please be aware, if you subtract the buying price now, we need to make plus, because the buying price is shown negatively. So if we calculate the net present value, you see that the total is 5.7 million, and that means we get 5.7 million more than if we put the 13 million to the bank with 10%. And that's the tricky part, because if we have another machine which gets us 30% of an investment, then we could apply 30%, and then the net present value would be negative. And then suddenly, with the same pricing and the same cash flows, you would see this as a not good investment. Whereas if we know that at the moment we don't get that much percentage at the banks, for example, if somebody gets 3%, that's quite good. If we put the 13 million to the bank for 3%, we get 12 million less than we get if we invest in this machine here. Now we have other kind of calculations we can do. For example, the internal interest rate, which is an IRR, the internal rate of returns for a series of cash flows. And here what we do is simply we take the cash flows including the buying price, and that's one of the reasons why the buying price here is negative. And you would see this would be resulting in an interest rate of 19%. Due to the fact that we have kind of an interest rate of 10%, we need to recalculate or modify that. This can be done by the modified internal interest rate, where we basically have the same stats. So we have the values, but here we have a finance and the reinvestment value. So we are looking at the money coming in and reinvesting the money with the proper percentage. And so in total, we're looking for this investment of an interest rate of 14%, which is not too bad at the moment. The annual profit is something we can calculate, which is a basically payment period. That means we can calculate for the payment per period, where we tell him, well, it's quite easy. We won't have those 10%. We are calculating for 9 periods. We have a present value of 5.7, but we need to make sure that this, if we give it away 5.7 and the future value will be 0, and if we do so, you see that we can extract from every cash flow 900,000 euro and at the very end get a net present value of 0. And due to the fact that net present value of 0 doesn't mean that we're not getting nothing, we get the 13 million with an investment of 10%. So that's not bad. So that's something we really can do. The net present value as a calculation is a quite nice formula, because what we can do here is calculate the net present value with the proper rate, and now calculate it only for the very first year, and then subtract the buying price. And that would mean after the first year, if you calculate down the cash flow of the first year with the annual interest rate, we are left with an investment of 12 million to pay back. And here it's quite easy, because if we calculate this for every year, we simply fix some of those parts of the formula, and if we now calculate it downward, you see that we have a formula without the formatting, which shows exactly that in year 6, from year 5 to year 6, we're becoming positive in terms of the net present value, and that means somewhere between year 5 and year 6 we're reaching our 10% return on invest for those 13 millions. And so if you have a second machine here and it gets about the same annual interest rate and almost the same buying price but different cash flows, you can calculate the net present value, the interest rate, the annual profit, and the dynamic amortization. And by comparing the two, you can judge which of the machines you would buy rather than flipping a coin. Okay, that was what we wanted to do with the financial mathematics. Be aware that there is a part where you can try out the same calculations as we did with the basic financial calculations, including payment per period. And here, at latest, it is important if you put a plus or minus in front of it. Thanks for your attention. See you again next time.